Good evening, Mr. Harry. Today, our group going to sort of explain for problem set number 1 from MIT. We are not we are not really answering the questions. MIT has already provided the answer for the solution for the problem set number 1. So what we're going to do this evening is trying to say it out loud, the answer. So for the first, there will be 5 sections. The first one would be explained by Yusuf.
Okay, section 1, positive versus normative statement. Identify whether each of the following statement is positive or normative. Briefly justify your answer. Number 1, the government has a duty to provide basic healthcare and education to every citizen. The first statement is normative as it provides an opinion about what the role of the government should be. Number 2, the cost of health insurance is too high. The second statement is also normative, science saying that it is too high is impactly expressing that it should be lower. Number 3, the median earning of a full-time worker with a college degree are almost twice as high as those of a high school graduate with no college education. Number 3 is positive. Number 4, the current unemployment rate is 3.9%. The lowest has been since December 2000. Number 4 is positive too. The last two statements are positive as they are just describing fact about the US economy.
Now we go to section number 2. Will be explained by Danniel.
Section number 2 is true or false. For each of the following statements, indicate if they are true or false. Justify your answer. Number 1, Bill is football coach. He evaluates his player based on 3 criteria: height, strength, and speed. Bill prefers one player over another if he is better in at least 2 of these criteria. Assume that 3 are no players with the exact same height, not the exact same strength, nor the exact same speed. A. Bill's preferences are complete. B. Bill's preferences are transitive. The answer A is a true. If we are comparing two players based on 3 criteria, it must be that one is better than the other in at least 2 of them, so we can always compare any 2 players. B. False. Consider the following counterplay. We have 3 players, A, B, and C. So A is preferred to B is preferred to C, and C is preferred to A, thus violating transitivity. Both are utility maximizing consumers given their income and market price and choose a bundle that gives her utility UN equal 100, while Bob choose a bundle that gives him a utility Bob equal 110. Therefore, we are know that Bob is happier than N. The answer is false. Utility is ordinal, so we can tell who is happier. The number 3, John's utility function for food, F, and clothes, C, is given by U. F or C equal, in brackets, F to the A alpha plus C to the alpha to the 1 per alpha with A greater than 0. Jones prefers satisfy the principle of diminishing marginal rate of substitution for any value of A. The answer is false. If A greater than 1, the indifference curve are concave, so they don't satisfy the principle of diminishing, or MRS. Number 4, Eva has preference over two goods that satisfy completeness, transitivity, non-satiation, and the inverse curve have a strictly diminishing marginal rate of substitution. Suppose that the price of one of this good increase in brackets and the price of the other one remaining the same. Claim Ava's utility must be strictly lower after the price increase. How does your answer depend on the composition of the initial consumption bundle? The answer is false. The utility can be higher after the price increase, but it could stay that same if in the initial bundle she was only consuming the good that didn't change price. If the initial bundle had strictly positive quantities of both goods, then we can tell the utility must be strictly lower of the price increase.
Now for section 3 will be explained by Dandel.
Section 3. Demand for video games. We have the following weekly demand data for the video games Grand Theft Auto or usually people say GTA in a US town. We also have the price data for a PlayStation at the same time. Here are the table of price and quantity. So number 1, write down the equation for the demand for GTA in the following form. Q to the demand G equal alpha plus beta G price G plus beta T price P, where quantity to the demand G and price G are quantity demanded and price of GTA. Price P is the price of PlayStation, and alpha, beta G, beta P are constant. The answer is, using the first two observation, we have that -5 equals delta quantity to the demand G equal beta P, delta price P equal beta P 10. So beta P equal -1/2. Using the first and fourth observation, we have that -1 equal delta quantity demand G equal beta G delta price G equal beta G. So beta G equal -1. We can then use any observation to find the constant. Alpha equal 216. So the demand curve is quantity to the demand G equal 216 minus price G minus 1/2 price P. Number 2. Does the demand function that you found in the part 1 satisfy the law of demand? Explain it. Yes, we have that beta G less than 0. So it satisfies the law of demand. Number 3, the supply curve for GTA in this town is quantity to the supply G equal to price G. Solve for the equilibrium price and quantity as a function of price P. How does the equilibrium price and quantity depend on price P? Briefly explain the intuition. The answer is, we find the intersection between the two curves and obtain PG, price of G, equal 216 over 3 minus 1 over 6 price P. Then quantity G equal 520 over 3 minus 1 over 3 price P. Both quantity and price depend negatively on price P. The intuition is that the increase in a complementary good, PlayStation, shifts the demand for video games curve inwards, leading to a drop in the equilibrium price and quantities.
Now for section 4 will be explained by Ray.
Section 4 in the French curve. In its the following example, the customers only to gauge X and Y based on the information given in each statements. Stats a possible set of in the French curve. Draw at a least two curve on a set of labeled X and indent to direction of higher utility. Then write down a possible from of the utility function u bracket x y that is consistent with your graph. Number 1, Alan likes wearing boots, right shoes, brackets x, and left shoes, bracket y. He always needs to wear them as pair. Having a right shoes is useless without the left one, and vice versa. Solution: right shoes and left shoes are perfect completes. So a possible utility function is u brackets x y equal mean brackets x and y. This is the graph. Number 2, Emma likes pizza bracket x but has vegetables bracket c. She only willing to eat an extra unit vegetables if she gets to eat an extra unit pizza. Solution: note that this case utility must be dersing in y and inserting in x. It must also safety then when we increase both pizza and vegetables by unit, the utility stay the same. Possible utility function is u bracket xy uncle x min y. This is the graph. Number 3, Mary like cooks bracket x and Pepsi bracket y. She is in the French Britain. Then as she is unable to tell difference between Coke and Pepsi. Solution: Coke and Pepsi are perfect substitutions. So a possible utility function is u bracket xy apa po sama dengan tadi?
Equal.
Equal x plus y. This is the graph.
So for section 5, utility maximization, Chloe consumes only books symbolized with X and video games symbolized with Y. Her preference can be represented by the following utility function. Utility xy equals x times y squared. The price of books is px. The price of video games is py. And Chloe has an income of $M. For number 1, write down Chloe's budget constraint. Chloe's budget constraint is px times x plus py times y less than or equal to M. That's the solution for number 1. Number 2, calculate the marginal rate of substitution, or we could say MRS. MRS equals to minus MUX over MUY, and we could also say it as Y over 2X. For number 3, find the equation that describes closed demand for books and video games for any possible value of Px, Py, and M. The answer, the setting MRS equals to MRT, and using the budget constraint with equality, we would get X equals M per 3 Px and Y equals 2M over 3 Py. That's for number 3. Then we go to number 4. Repeat part 3 when the utility function is u xy equals minus xy. Solution, with this preference, the consumer will always choose bundles such that x equals y. Replacing this condition in the budget constraints, then we would get px times x plus py times y equals bracket px plus py times x equals m. Then we would get x equals y, then it would equals m per px plus py. Now we go to number 5. The question for number 5 is, let us now go back to the original utility function u xy equals x times y squared. Suppose that government impose a tax on video games such that if the price of a video game is py, the consumer must pay 1 plus tau times py. What is the new demand function for video games? Plot the demand before the tax and after the tax in the same graph. Note, you don't need to assume any particular value for m tau. It is enough to provide a quality graph. Briefly explain the intuition. The solution for number 5, the new demand of function is y equals 2m over 3 bracket 1 plus tau times py. So the new demand function is down and to the left of the original one. The intuition is that for any given value of py, Chloe now has to pay a higher price, so she will demand a lower quantity. So now we go to the last question, number 6, in section 5. Let's go back to the case without taxes. Suppose that px equals 2, py equals 2, and m equals 30. Suppose that Chloe has one quote-unquote buy to get 10 free coupons for books. Note that is, she will get 10 free books if she buys at least 10 books. So how many books and how many video games will Chloe consume? Carefully draw the budget set and the highest attainable indifference curve on the graph. Here we have the graph and the solution. The highest indifference curve will be either tangent to the budget constraint or will pass through the king at the bundle 20 and 5. The only tangency point is at 5 and 10, and evaluating the utility function at these 2 points, we find that utility 20 and 5 equals utility 5 and 10 equals 500. So Chloe is indifferent between buying xy equals 5 and 10 or using the coupon and getting xy equals 20 and 5. So now we have explained from section number 1 until the last section, section number 5. Thank you.
Thank you.
Wes, mari.
Tai.